Yes, hi everyone. Boy Christmas Ben is my name, together with Mungabezi Griven, Samaganda George, and our project is titled Trustworthy Intelligence Simulator Forecasting Tourism Demand. Um, First of all, when we look at the background and introduction of our project, when you look at tourism as or the economic importance of tourism, one, it is a great contributor to global economies as well as in local ones. It raises the GDP of the states. It also fosters job creation and infrastructure development. The vulnerability of tourism is that one, it is sensitive. It is a greatly sensitive economic activity in that it notices or it is affected by economic shifts, political instabilities, environmental changes, as well as global events, which triggers the need for accurate forecasting essential. Uh, the great objectives or the objectives of our project is to develop an intelligent AI simulator, which is whereby we use machine learning and the simulation techniques to accurately forecast tourism demand. And the other one is to implement adaptability in that the system should adjust automatically or should adjust to various scenarios, thus providing reliable insights to the stakeholders so that they can make informed decisions in a dynamic environment. Then, looking at the literature review, we happened to review a number of papers, though we have a few listed here. One, we have the cloud-based real-time tourism demand forecasting system with deep learning, whereby the approach challenge was real-time forecasting solutions to enable timely operating decisions and planning. There was a need for that, which was not being achieved with using the previous or the existing models. And therefore, the solution they suggested was to develop a cloud-based architecture using the LSTM for real-time, scalable, and accurate tourism demand forecasting. The limitations that they encountered, one, they were limited to high-frequency internet data, which lacked integration of offline data sources, which would provide a holistic view. Then also looked at forecasting of short-term tourism demand based on multivariate time series clustering and LSSVM machines. Uh, the computational problem in this sense was the inefficiency in using single models to predict short-term demand accurately in fluctuating periods. And the suggestion they provided in this case, the solution they provided was to combine time series clustering with the LSSVM to reduce overfitting and capture varied demand patterns effectively. Likewise, the limitations, we had a complexity in analyzing short-term tourism demand trends due to variations across the different time periods. The other was deep learning frameworks forecasting tourism demand, whereby we had a difficulty in capturing nonlinear relationships in time series data. Remember, we have a lot of seasonality in some forms of time series data using the traditional models. And then the solution that was suggested is utilizing the LSTM and GMF to handle nonlinearities in time series data and improve prediction accuracy. The limitation was that there was the inability to incorporate external qualitative variables like social or political events. That was, yeah. These, among others, were some of the papers I tried to review in relation to the topic. And the computational problem in this case that we have the traditional models that are in place are limited to invariant time series data, which makes it difficult in capturing, which the traditional existing models are limited to univariate time series data, which makes it difficult in capturing the influence of other factors in tourism, hence inaccurate predictions, as well as uh, since they have an issue to deal with data complexity, which makes it difficult in learning underlying patterns in the multivariate data sets, which calls for precision and enhancing prediction. The proposed solution in this case was to develop okay. First of all, the overview is to develop an intelligent AI simulator whereby it use machine learning and simulation techniques. And the key features we are leveraging in this project are one, we have multivariate data analysis, where since we are dealing with multiple factors that are to influence the forecasting process. Then we're also looking at scenario analysis, since we were looking at implementing a simulation using any logic. We're looking at real-time analytics, real-time prediction, since we are wanting this system to be adaptable. Then I also want seamless integration via API. Um, the methods forecasting, we have looking at the ARIMA, which is the time series model, which is the autoregressor integration, moving average. We're also looking at the perfect model, which is as well the time series data model. Then for machine learning, we are looking at a random forest regressor, gradient twist. We're also looking at the linear regressor model, the decision tree regressor model, and that we didn't include them in the slides, but then we implemented them in our code. The simulation environment we have to use is AnyLogic, which is to do scenario analysis as well, and impact assessment. Some of the evaluation metrics, mean absolute error, these metrics basically point out the difference between the actual and the predicted values. Then the novel contribution one is that since most of these models are black box in nature, we are looking at implement our providing transparency for them through explainability techniques. For example, I mentioned that we implemented for our models. Then we're also looking at an intelligent AI simulator that is to forecast the tourism demand, and also a simulation environment, yes, please, for these economic downtrends and then downturns, and then the natural disasters as well. Then also implementing an API for simulation integration that we shall freely distribute to the tourism boards along with them. And the dataset that we use, it was collected over a period of 10 years. It had total entries of 3,653. And they were labeled in days, but then they are entries in this case. Then we are leveraging 4 companies that are going to work that are to serve as our target variables. There was an accommodation company. There were two transportation companies, and then there was one indoor leisure activity or one indoor leisure facility company. Yeah. So we are trying to use that data as our target variables in that we are predicting tourism turnout in relation to accommodation, transport, and then the indoor leisure activities. Then it had 562 columns in total, where 4 of them were the target variables, and clearly lightened up. The next slide. Then this dataset contains different aspects. For example, the calendar effects, which were in days, weekends, and then months. We had also event data in terms of the holidays, public holidays, vacations, and weather aspects as well in there. And the purpose of this data setting from the source we obtained it from was to analyze the short-term demand fluctuations to improve forecasting and decision making for tourism stakeholders. And because of this reason, we found it wise to leverage it for our project. The missing values is that in the 2 target variables that we had under transport had 12 missing values, and then and the indoor leisure activities we had 42 missing values in that. But then all these values were made available in masked columns. Yeah, there are 2 columns that were masked, one which was for transports too, and then indoor leisure activity. They were masked. So in the data pre-processing, we just got these values and then had to input them in where they were supposed to be. Then data types, all the data was in integer data type, an integer of int64. Yeah. So during our EDA, these are some of the visualizations we obtained. For one target variable, which is accommodation, that we are trying to visualize, we're observing a normal distribution, whereby on the x-axis we are having a tourist turnout in relation to accommodation, and then on the y-axis we are seeing the frequency at which that tourism turnout happened. And we had the highest turnout at around an index of accommodation of 87%, which had a frequency of about 270. And then now at an accommodation index of 5, we observed a 0 frequency, meaning there was no point in time whereby there was no point in time whereby at an index of 5, we observed there was no repetition of 5 of the index 5 in the accommodation sector happening. Then the other target variable of transportation, we observe a skewed graph, which is greatly skewed to the left. And then an implication that, okay, we had a range from 0 to 10,000 in the turnout of tourists in relationship to transport. We had but the graph is greatly skewed to the right, and implicates that most of the tourist turnout was greatly distributed to the left, though not normally distributed. So, uh, yeah, basically that. Then going on to our heat map, the heat map basically shows the interaction or the interaction between the different features of the data set. Yeah, and it represents this using the power of colors. We observe for three colors. We have the dark red, deep blue, and then the blank. The blank represents a no correlation, and deep blue indicates a strong negative correlation, and the dark red or the deep red is basically for the strong positive, and it is usually a self correlation between the factors. The target variables are clear and stipulated, where we have the accommodation, transport one, transport two, then the indoor leisure activities. Then the key correlation, we observe the highest positive correlation of 0.75 between the temperature and transport one, and then the greatest negative is between accommodation and wind, and then the other less negative is between and the indoor leisure activity and transport. Then our methodology that we have to follow in this case one, uh, through our course, this is the methodology we have to follow. It starts with the obtaining of the raw data, basically which is downloaded from the web from an open source website. We downloaded that data and then we went on to perform data preprocessing. We talked about imputation of the missing values in the two target variables, which were provided in the masked columns. Then for the other columns, we just did the imputation using the mean. Then we also went on to perform EDA. That's where we happened to obtain the visualization of the heat map and the histogram. Then we also went on to also went on to move we moved on to model implementation and training, which involved splitting of the data into the training and the test set. And we implemented and trained the models. Afterwards, we went on to perform model evaluation using the metrics we provided, the mean squared error, the root squared error as well. And then after the evaluation, we went on to do hyperparameter tuning and then re-evaluation. After which, we went on to perform explainability using Lyman Sharp, which is observed right here. Explainability using Lyman Sharp, purposes of transparency, and then meeting standards. And thereafter, we have to move on and implement our simulation using any logic after performing model selection and then observing how perfectly each of the models perform. Then we go on and implement our simulation. After that, we implement our UI. Remember, it has to, for purposes of interaction with the users or the stakeholders, it must have a friendly user interface. So we have to do that. Then afterwards, we shall implement the API, since we are looking forward to distributing system to some tourism boats, have the API. Then afterwards, we shall perform model deployment, purposes of scalability. Now, here, you'll excuse me for this missing column. Some of this metric, the last one, was not applied to all these models, but then it was applied to only the perfect model, which again didn't use this simply because we happen to get conflicts when we're leveraging them. So these are some of the results for the XGBoost, the linear regressor, random forest regressor, and decision tree regressor, whereby the linear regressor, the reason that's why it is bold is that I happen to provide the best performance amongst all of these. Yeah, had the best performance and implication that it was properly capturing the underlying patterns in the different factors that influence the tourism forecast. Then the ARIMA model had two implementations. You had the manually implemented and then the automatically implemented. And the manually implemented model had a better performance compared to the automatically implemented. And this points out the fact the selection of the parameters. Remember, ARIMA has three. So it has the A, auto-regressor part, which is for P, and then I, which is the Q, that is the degree of differentiation, and then which is the moving average. So the manually implemented one, we had a perfect selection, which was 210. That implies that the parameters that we selected for that model were the best fit for it. That's why it went on to clearly pick on to understand or to study the patterns, the underlying patterns of all the data, the underlying patterns in data that we're trying to interact with. And the model diagnostics here indicate that when we plotted the residue, we observed a normal trend, an implication that there was a perfect or the model clearly tried to capture the underlying patterns, and as well as the density of the residue distribution we, despite the fact that it is narrow and long, it implies that still the model and the residues that exist in the data were normally distributed, and the model perfectly picks out the aspect that it wanted to, and it needs or it desires to perform properly. Then explainability of some models, for example, the linear regressor here, we are observing that the line basically provides a local explanation towards them for purposes of model performance. It basically points out the factors that contributed the greatest to model output. So for this case, we are observing holiday and weather summary category, which points greatly to the out which contributed positively towards model prediction. Now moving on to Sharp. Sharp is it provides a global explanation whereby it describes or it explains the contributions or the influence of all factors towards model prediction, whereby the pink values indicate the high contribution and the blue values indicate the low contribution. And for this case, the external event is stagnant at zero, an implication that it had a low impact on model output. And then when you observe the holiday has a great contribution, likewise to temperature, and then sunshine and local events as well. Likewise, the XG boost, but the XG boost in the line graph, we're observing that still holiday had the greatest contribution towards model output. And then in the sharp graph, we see that holiday has a great high sharp value, and then temperature as well. So we also had a great influence towards model output. Thank you so much for today. That's all we have. For the poor results here, we are trying to do more analysis for implementing cross validation, and as well as trying to implement techniques such as SMART to make sure we attain good results before we move on to our simulation. Thank you so much.